detailed about the one memory cell. Okay, one memory cell, I already told you, it can hold one bit of 0 or 1. Okay, one memory cell. Okay, so this one memory cell. So how do we classify one memory cell? Now we'll see that memory cell is classified by the number of stable states. That means number of different symbols it can store. For example, in binary it can only store two things, 0 or 1. That means plus supply voltage is plus V volts for 1, 0 volts. Okay, for 0. Okay, this is in binary system. For example, if a memory cell which can store 10 different values, I mean 10 different stages, then it is called stable states are 10 different stable states. Then it can store 10 different values. Okay, you understand? Like that, it can store 10. But in binary system, most of the cells will store only, most of the cells either it contains 0 or 1. Okay, 2 states only. Okay, means 2 stable states. Stable states is nothing but either plus volts or 0 volts. Okay, then memory cell is also classified and based on the power supply. Power supply means when the memory cell is able to retain the data, whatever it is there, even when the power supply is gone. Okay, then it is called non-volatile. Okay, otherwise it is called volatile. Volatile means when the power supply is gone, whatever the data is there, it will be go away, it will gone. Okay, then it is called volatile. When the power supply, non-volatile means even when there is power supply is off, the data will be still be there. Okay, that is called non-volatile. Then destructive and non-destructive. Destructive and non-destructive means, see, for example, data is there. For example, capacitor. Take a capacitor. Okay, voltage is there. This is 1 volt, representing 1 volt. Okay, this is a transistor read signal. Destructive means it is already charged to 1. Okay, for example, if you want to read this data, okay, 1 volt, because it is 1 volt means this voltage means 1 indicates 1. If you apply read signal, okay, what will happen? This capacitor will discharge. When we are reading this data, output will get the 1. Okay, 1 volt, but it will discharge through this path. Since the capacitor, it will discharge. That means reading operation discharge and this voltage will collapse. Okay, here what does it mean? Reading operation is destructive. Destructive means existing data will be lost when we are reading the data. Okay, that means memory cells are also classified on destructive and non-destructive. Destructive means when we are reading, if the data is lost, then it is called destructive type of memories. Okay, like if you take the flip-flops, even if you read the data, even if the power supply is gone, even if you read the data, it won't be destructive. So those are called non-destructive. You understand? While reading, if the data is lost, here we are discharging. So if data is losing, we are losing data. So destructive and non-destructive. Okay, then read time and write time. So these are important parameters. I already told you the time required to write a data to the cell and the time required to read the data from the cell. This is read time and write time. Okay, that is important. And another characteristic is that read-only memory. Read-only memory is that read-only memory cell means that once it is programmed, once it is written, it can't be rewritten again. Okay, then we can only read that memory only, but we can't write it to again. That is called read-only. So these are the basic properties of a memory cell. Okay, then we will see the more about that, more detail about memory cell. Take a single memory cell. Okay, this one. So what are the controlling for a single memory cell? What are the controlling signals? There can be a read signal, read command, and write command. Okay, from that cell. So whatever data we can write it to data. Then there is input. Input when we require. If you want to write the data. Okay. Output. Output means when you want to read the data. If you give the read signal, it will give the output. So whatever data is there, either 0 or 1, it will give the output. So if you want to write the data to here, you will give the input 0 or 1 here, it will store in this location. Okay, this is one single cell. I told you word, meaning of the word. Word means group of addressable cells. Okay, group of addressable cells. So you take three cells in parallel. You take 3 cells. For that 3 cells you are giving equally same read signal, same write signal. That means at a time you can read the 3 cells. For example, 3 cells you take. 3 cells. Okay. Cell 1. cell 2, cell 3. Okay, you are taking 3 different cells. Input. Okay, for 3 cells 3 different inputs. Okay, same time output. Okay, these are 3 different cells. You are giving 3 inputs, 3 output, but you are giving single read or write cell. That means single read command and single write command. What does it mean? Read. That means for all these cells you are giving same signal, one read signal. Okay, you understand? One read signal means, that means if you give the read signal here, that means all these 3 cells will be activated at the same time. That means you will get the output all the 3 bits, whatever 3 bits are there. That means, for example, take 0 1 0, like this data is there in these cells. So what will happen if you give the read signal? Okay, read signal, what will happen? This data will come out. That means 0 1 0. That means this is a set of cells interconnected. Set of cells interconnected. Here how many cells? 3 cells. That means it is also called 3-bit word. You understand? This is also called 3-bit word. So here at a time you are able to read 3 cells. Okay, this set is called a register. The number of cells interconnected is a register. More precisely, you can say that 3-bit register. If there are 4 cells are connected like this, for example, one more cell is also connected, for that also read signal is common, then it is called 4-bit register. Okay, this is called a group of cells connected together is called a register. Okay, you understand? So similarly for this also, write command is also same write command, single write command. Okay, if you give the input data, for example 1 1 1, okay, you give the write signal, what will happen? It will write at a time all the 3 cells. One will be written, one will be written, one will be written. Okay, this is called parallelly we are doing 3 cells. That means 3 cells are connected to the same write signal and same read signal. Okay, this is what we call it as 3-bit register. Okay, this is one register. Take for example, there are 4 registers are this is one register. Okay, 3-bit. For example, replicate all these things 4 times, then it is called 4 bits, 4 words. 4 words, what do you mean? I'll explain. This is one register. So if there are 4 these type of registers, what does it mean? If there are 4, what will happen actually? For example, this is one register of 3-bit. So similar, there are 4 sets like this. Okay, for each one has the same read and write. This is one read and write command, that another cell will has another read and write command, like that. There are 4 sets. Okay, okay, what does it mean? Okay, I'll just go 3 words. We are talking about 3 words. No? See, here it is a 3 word register. Okay, 3-bit register. So one more 3-bit register, one more 3-bit, one more. So there are 4 bit. So entire set is like that. These same signals are replicated here. So entire set is called, what we call it as 3-bit. We also called it as 4 registers of 3-bit. Okay, 4 registers of 3-bit, because each one is a 1 register. This is 1 register set of 3. This another 4-bit. So we have to differentiate between while reading or writing, because we are giving read signal and write signal at a time. You are parallelly able to reading. So while reading or writing the data, you have to differentiate which one you have to select. So first you have to select which register you are going to read or write. For that purpose you need to address it. Okay, for example, these are four registers. First register 1, register 2, register 3, register 4. Okay, 4 registers. Okay, so if you want to read the data, which register you want to read the data, for that you have to address, you have to give the address to each one. So you know that if there are 2 bits, how can you address, how can you logically connect these 4 things? For example, take, if there are 2 bits, how many combinations we can form? 2 bits means 0 0 0 1 1 0 1 1. Okay, in order to address 4 we need 2 bits. Okay, that means, for example, this register is assigned with address of 0 0. This is 1 0 1 1 0 0 1. Okay, that means 2-bit. If there are 2 address lines, these are address lines. Okay, if there are 2 address lines, that means 2 lines. Okay, 2 address lines, that means we can address 4 registers. Okay, you understand? 2 address lines, 4 registers. Okay, you understand? 0 0 0 1, like that. For example, if the address is 0 0, it will select this first one and give, depending upon the read or write command, it will take the data from the upper register. Like that, if you give the address lines in 0 1, it will take the second one. 1 0, it will take, depending on the command, it will read or write. Okay, you understood? Okay, if there are 2 address lines, we can address 4 registers. Similarly, 3 address lines. 3 address lines means 3-bit. How many registers we can address? We can know that 0 0 0 0 1 0 1 0 0 1 1 1 0 0. Okay, 1 0 1 0 1 0 1 1. Okay, you know that we can address 8. For 3-bit we can address 8 registers. Okay, similarly 4-bit means 2 power 4. 5-bit means 2 power 5. Like that, if there is n-bit address lines, how many different registers you can address? 2 power n. Okay, so here, and one more thing, here we have taken just interconnection of 3 bits, but memory is usually defined as in terms of interconnection of 8 bits. 8 bits, most of the times we will represent memory as 8 bits, set of 8 bits. Okay, set of 8 bits means like set of 8 cells as one word. 1 2 3 4 5 6 7 8. Okay, like this, 6 8. Okay, this is 8-bit. 8 cells are interconnected. Okay, at a time we can read 8 cells. Okay, so this is called 8-bit register. 8 bits also we can tell it 1 byte. 8 bits equals to 1 byte. Okay, so 1 byte register. Okay, so like this, if there are, for example, if there are like this, four sets are there, that means 2 address lines we require. Okay, 4 sets. If there are 8-bit, 4 sets are means there are 4 Same analogy you apply to that 8 bit. Okay, 8 bit, for example, these are 8 bits. There are 4 sets like this. Okay, that means you require only 2 address lines to address 4 cells. Okay, to repeatedly. That means it is called 2 square into how many cells are there? 1 byte or 8 bits. 1 byte. That means it is called 4 byte memory. You understand? 4 byte memory means there are 4 registers. Okay, each register contains 8 bits. 8 bits is nothing but 1 byte. Okay, 8 bits is nothing but 8 bits equals to 1 byte. You understand this? That means if there are 4 address lines and 4 sets are there, then it is called 4 byte. That means 4 into 1 byte. That means 4 into 8, 32 bits. Okay, each byte contains 8 cells. Okay, like that, if there are 10 address lines, okay, how much memory we can form? Tell me how much memory if there are 10 address lines. So if there are 10 address lines, each address line is pointing to 1 byte. Okay, that means, for example, 2 address lines means 2 power 1, 2 square, sorry, 4 words, 4 bytes. Okay, it can address 4. Or if there are 3 address lines, 2 cube, that means 8 bytes. Okay, like this. If there are 10 address lines, 2 power 10. Okay, that means 1024 bytes. This is also called in computers, it is also called 1024 is a kilo. We'll tell it as a kilo, not 1000 here it is 1024. So 1k bytes will be represented B. Okay, if there are 10 address lines, we can address 1 kilobyte. Like that, if there are 20 address lines, how many we can address? 2 power 20. Okay, 2 power 20 is nothing but 2 power 20 is the capacity. So 2 power 10 into 2 power 10. Okay, you understand? 2 power 10 into 2 power 10. Then it is called 1 kb into 1 kb. So you know that kb into kb is nothing but mega. So 1 megabyte, 1 mg. Like that, if there are 30 address lines, 2 power 30. That means 1 kb 3 times 1 kb 1 kb. This is called 1 gigabyte. Okay. If there are 2 power 40 address lines, then it is called 1 terabyte. Okay, you understand how the memory is available. So each address location is roughly approximately address 8 bits, 8 cells. Okay, one address, that means it's like one home you are addressing. If there are multiple homes, okay, you take the rooms in the house. Actually, in each house it contains 8 rooms. Okay, like that. So you'll address them, you don't address the independent rooms, you address only the house number. Okay, inside the room there are 8 cells, like that. 8 cells means 8 cells are interconnected. That means in each house there are 8 rooms. Okay, in each one room we will store one data. Okay, like that, this is memory organization will be done. Okay, this is how the memory capacity will be defined. We'll draw the one more diagram. So for example, I'll just draw the simple diagram, 4 bit only. This is the memory. Okay, 4 word memory, 4 into 4 bytes. Okay, 4 bytes. I'll just write the 4 bytes means there are 4 addresses. That means 4 different houses, like that. Okay, each house contains 8 bits. Okay, so in order to address, we need 00, 01, 1011. That means 2 address lines you require. Okay, 2 address lines. Okay, what will usually, this is the memory, this way the memory will be stored. Okay, so now address, there is a decoder or selector. Decoder or selector. What will happen? Computer CPU will place in memory address register. You already told memory address register. Okay, here there are 4 address registers. Okay, so computer will place in memory address register. It will place the address where it is had to read the data. Okay, so what will happen? 2 bits. Okay, address lines are 2 bits. Now what will happen? For example, it placed 01. Okay, so it will go to 01 will be coming in the, this is address bus. Okay, memory address register, this is address bus, so it will come to the here selector. So 01 means it has to select, so this line will be selected. Okay, it will be selected and concerned 8 bits, concerned byte will come out. 8 bits na, for example 1 2 3 4 5 6 7 8, concerned 8 bits will come to the, this is bus, this is also called bus, this is data bus now. So where will it store? Memory data, MDR, memory data register. Okay, this is a buffer actually. So when it is, processor will place the address in memory address register and it will give the address. For example, it is giving 01. I am taking simple example actually, 4 byte only. So 01. Now it will go to the selector. It will, there are 4. So it will select the 01. Okay, the corresponding byte will come to the memory data register. Okay, this is for read operation. For write operation, what will happen? The processor will place the same address and it will give the data to place the data in the here. So processor, if this is the processor, it will place the data here, address here. Okay, if it want to write the data, so if it want to write some data, okay, what will happen? It will place the data in the memory data register. Okay, data will come to here. Okay, then it will place the address, which location. For example, if it is want to write in 11 location, now it will come the 11 location. Okay, now the memory data is already, memory data register data is there and it will, one location is selected and data will be written to this location. And in addition to these 2 signals, processor will also issue the write signal because it has to write. Okay, here processor will issue the memory address register, data, memory buffer register and read signal or write signal. This is the control signals. Okay, this is the way simple memory address. This is the way how the processor reads and writes from the memory, and this is the way how the memory is selected. Okay, we can also choose that. Simply you can say that, for example, we are very familiar with the terms. For example, there is reverse way of asking. 64 kilobyte memory is given. What does it mean? What does it means 64. Okay, kilobytes. Okay, kilo means, you know that in computer terminology 1024. 1 byte, B means byte, 1 byte means 8 bits. These many bits of data. Okay, this is one way of interpretation. 64 kilobits means 64 into 1k and 1024. 1 byte means 8 bits. Total, these many bits. Okay, these many zeros and ones are stored in that, can be stored in that memory. One more way, if you want to, if the memory is given 64 kilobits, how will you represent? Okay, take, this is 64 kilobit. So how many address lines are required to address this one? How many address bits otherwise required? This can be a question. Okay, how many address lines? So how will you do that? It is given 64 kilobyte. Okay, that means how many address lines required means how will you do that? Kilobyte means memory is organized as a set of bytes. 1 byte contains 8 words. Okay, that means in output it will give 8 bits at a time. 4 4. Okay, 8 bit output. Then 64 kilobyte, how will you address this? 64 means you can say that 64 KB, okay? You know that 64 means 2 power 6, okay? 1 kilo means, you know that 1 kilo means 2 power 10, 2 power 10 bytes. So each word, each register contains 1 byte, okay? You know that register is addressed as in terms of byte. That means one time you read that, okay? That means bytes, that means 2 power 16 bytes. That means how many address lines are required? 16 address lines. That means 16-bit address bus is required. Okay, 16-bit. Similarly, you can do that for any operation. For example, 256, like 512 KB given. How many address lines it can be required? 2 power 10 into, this is 2 power 9. That means 2 power 19. So, in order to address, there are 19-bit address bus is required for 512 KB. Okay, like that you can calculate how many address lines are required. Here it is 16 bit address bus is required to identify this address. Okay.